right now, I would like to welcome to the stage Cătălin Cosoi and Silviu Sofronie from Bitdefender to speak about a look into Bulletproof hosting. So let's give a round of applause to, yeah? Come on.
Good afternoon. I'm Cătălin. This is Silviu.
Good afternoon.
It works. I know we are a security company. Most of you guys know us for our AV products. But this is not going to be any commercial presentation. We're going to go to present you some of the challenges and projects that we have, and also pay a lot of attention because we're hiring exactly on these projects. Silviu.
All right, so we're going to take a look into Bulletproof hosting, what Bulletproof hosting is, why it exists, who uses it, and how we think it will evolve in the near future. So in order to make these points, we're going to go through some Gameover Zeus information, CryptoLocker, and some Tovar hidden services. It's going to be quite a technical presentation. Hopefully, I'll be able to keep my mind throughout the presentation. First of all, why does Bitdefender do forensics? Because we have...
To get on the other side?
What?
To get on the other side?
No. We have access to 350 plus security specialists in their own areas, so we have access to guys who know networking, operating systems, malware research, phishing, spam, whatever it is. We also own a network of honeypots that are deployed worldwide to provide us with real-time feeds of malware samples, spam, phishing. Our IP reputation systems and URL blacklists are also a very valuable tool. We crunch our big data through the use of correlation engines and machine learning algorithms in order to have a good understanding of the big threats, the emerging threats. So how do we do a forensic investigation? First of all, we recognize the big threat by using the tools I just described. Then we break it all apart, piece by piece, look at each piece, and try to understand how it's working in order to move up the chain and do an effective takedown of the botnet in this case. All right, so speaking of botnets, we're going to go into Gameover Zeus. And first of all, how can you become a victim of Gameover Zeus? Its main attack vector is spam campaigns with malicious attachments. But we've seen that drive-by downloads and phishing schemes are also a good, effective infection vector. So that's how they reach you, but who could actually become a victim of hacking? I think Cătălin could.
I wasn't paying attention. I was saying hi to somebody.
That's why he can become a victim of hacking. But also some other people got burned. So nobody's actually safe from hackers if they put them from you, if they put your mind to it. But we can split the hackers into two main categories. We have the hacktivists, the hackers that do political hacking, governmental sites, and the most serious hacking group, the cybercrime groups. These guys do hacking for profit, for making money. So it's necessary for them to have their server infrastructure operational at all time because they make money out of it and they need as much money as possible. So in comes the need for a bulletproof hosting service. So this hosting service should be bulletproof because from the police and the security industry in order for them to make a lot of money. We're going to look Gameover Zeus, but it's an interesting botnet in this case. First of all, you can see the architecture of the botnet. You can observe that the network is peer-to-peer. Every victim communicates to a list of peer victims. And the command and control server in the bottom right, is this the pointer? Okay, this is the command and control server talking to only one infected machine. And this infected machine communicates to other victims and the victims to each other and so on. This makes it difficult for the police, for the law enforcement to find out the real CNC server, because if they investigate this machine, they'll think that this is the actual CNC server because this is where the instructions come from. This is a very interesting approach and different from classic botnets which have every victim connecting to the CNC server. Every victim in the botnet knows the IP address of the CNC server, which is rather useless, because if you take down the CNC server, you're taking down the whole botnet. So the guys thought of using domain names instead of IP addresses, and they're using domain generating algorithms. These are algorithms which provide the victim with a list of domains at which they can find the CNC server. These domain names are active for a specific period of time. In the case of Gameover Zeus, we have 1,000 domains per week used by the victims to try to contact the CNC server, in sequence, one by one, until the CNC server answers. Right. So now, a little bit about CryptoLocker. CryptoLocker, being a ransomware, has nothing to do with a botnet, actually. It encrypts your file system by the use of a public key, and the public key has a corresponding private key which could decrypt your file system, but the private key resides on the server of the CryptoLocker guys. So the CryptoLocker guys had this awesome malware that encrypts your file system and asks for ransom money, but they needed a way for the victim to talk to their server, because you can notice here that the victim needs to talk to the actual server for the CryptoLocker guys. So that's where CryptoLocker guys used Bulletproof hosting. In our forensic investigations, we found a Bulletproof hosting that actually serves 10 clients. I'll get into that a bit later. The interesting connection between CryptoLocker and Gameover Zeus is that Gameover Zeus was used as an infection vector for CryptoLocker. So every victim of Gameover Zeus received an instruction to download and install the malware from CryptoLocker. So the police got on the wire because there were hundreds of thousands of victims.
I don't know about victims, but they were making 20 million as profit.
20 million, okay. So the police, the law enforcement agencies got on the wire trying to stop the spreading of CryptoLocker. And to do that, they needed to take down the Gameover Zeus botnet, which was actually spreading the malware. So Operation Tovar happened sometime last year. I don't remember the exact date. It's not important. Operation Tovar was a joint effort by the FBI, Europol, Cyber Security Task Force, local law enforcement, security vendors, security industry. What they actually did was cut off the communication between this is the pointer, between the CNC server and the affected machine, because all that 1,000 domains per week were not resolvable anymore. The DNS didn't answer for them, nobody. They got a Department of Justice court order that prohibited every internet service provider to resolve the domains belonging to Gameover Zeus. So that's how they stopped the communication between the victims and the CNC server, hoping that CryptoLocker would stop spreading, which was an effective takedown. It worked, but it had nothing to do with CryptoLocker, because CryptoLocker was using a separate infrastructure. After the infection with CryptoLocker, the victim didn't need Gameover Zeus anymore. The victim had CryptoLocker and needed to get the public key and the private key from a separate set of servers than those from Gameover Zeus. So basically, we're speaking of a victim that now is talking to the CryptoLocker Bulletproof hosting services that provide the victims with the public key to encrypt the file system. Now, this infrastructure of Bulletproof hosting we studied because we did a forensic investigation on several servers with the help of our friends from law enforcement and local certs. And we've seen that the Bulletproof hosting is layered in multiple proxy servers. So we have at least 2 proxy servers which stand behind the victim, between the victim and the actual CryptoLocker server. These servers are being used, this infrastructure is used in order to anonymize and hide away the real server for CryptoLocker. Yeah. What we found out, and it's interesting that the Bulletproof hosting had 10 clients, including CryptoLocker. So there was CryptoLocker, but also other big threats that were using this infrastructure to hide away their servers. So not only CryptoLocker was using them. Now the proxy layer 1 server, the first line, the first circle, is facing the victim, and it only relays traffic from the victim to the proxy layer 2 server. I have an example of exactly how it works. So let's say you become a victim of CryptoLocker today. CryptoLocker has some domain names that the victims use to connect to the server. So you have a DNS request up in the top corner right here, port 33 domain. The victim makes a DNS query. The DNS query is answered by the name server for that specific domain. As it happens, the name server is actually a proxy 1 layer in the Bulletproof hosting infrastructure. So the proxy layer 1 server receives the request, DNS request. It sees that it's from a CryptoLocker victim. So when it contacts a central DNS server, this is a private DNS server hosted within the Bulletproof hosting infrastructure. So this DNS server receives the request from the proxy layer 1 server. But because the Bulletproof hosting has more than one client, it has 10 clients, it needs to differentiate between Citadel victims, CryptoLocker victims, fake AV victims, and other clients. So every proxy layer 1 server attaches a random number, which is specific to CryptoLocker, for instance. It's the Y here. So the DNS server now knows that the DNS query was made by a client, by a victim of CryptoLocker. So it answers with 4 IP addresses for CryptoLocker, telling the victim, reaching back to the victim with 4 IP addresses for servers which belong to CryptoLocker alone. The victim then connects to one of those IP addresses via an HTTP request. This HTTP request actually is trying to get the public key, is the malware calling home to get the private key for encrypting the file system, right? So the victim begins a connection on HTTP, proxy layer 1, proxy layer 2, because it forwards the traffic HTTP, and from proxy layer 2, you have VPN tunnels leaving proxy layer 2 to other servers which are proxies, and the cycle can continue until one of the servers decides, I will end the cycle, and now I can talk to the real CNC server from CryptoLocker. So it's a very, very complex infrastructure with proxy servers in and between each other, trying to hide away the path toward the real server from CryptoLocker. But still, the victim can access the server from CryptoLocker without any problems. Okay. So we did a little bit of forensics. And after Operation Tovar, the takedown of Gameover Zeus, the main infection vector for CryptoLocker, we've seen that CryptoLocker is still alive, and it also started to use Tor functionality. So they started to move towards Tor because it was hard. It becomes harder for the law enforcement task forces to take down servers in Tor, Torified servers. We've seen in October 1,703 requests in 24 hours for the service of CryptoLocker. These are requests made by the proxy servers between each other. These are not the victims, are the proxy servers calling back home for updates. This isn't my presentation. I have a whole bunch of stuff on Tor as well, so let me just check out. Cătălin, talk.
I need to entertain the audience. So who's with me so far? Do you like the presentation? Can I get a woo woo or something? Or you're not that kind of audience? Am I doing it right, Silvio?
Sorry, I'm not listening.
Yeah, they usually call me here for when there's technical issues, so I can act like a monkey or something.
Right.
I can go back.
Wait a minute. Okay, so we were discussing that Bulletproof hosting. Thank you, Cătălin.
Welcome, sir.
Bulletproof hosting services have moved towards Tor functionality, okay? So let's talk a little bit about Tor and how it works. We'll just take a classic example of a client connecting to a hidden service in Tor. This is done via 7 steps. The first step is for somebody to put online a hidden service. So we look at the bottom of the picture. The hidden service needs to become available in Tor. In order to have a hidden service available in Tor, you need to generate a public-private key pair, then do a full SH1 digest on the public key, After a base 32 encode of the result, you take the first 10 bytes and oh, and behold, it's Facebook or wwwi. It's actually the hidden service for Facebook. So now you have a name for your hidden service in Tor. You now need to go to step 1. Roughly, what happens is the following. The hidden service chooses some introduction points, then talks to a hidden service directory, much like a DNS server. Then the client can go to the hidden service directory and find out about the introduction points that your hidden service has chosen. After that, the client contacts the introduction points and gives them a rendezvous point. A rendezvous point is the point where the hidden service and the client will connect with each other. We'll go through each of it so you'll understand better. After you have found out what your onion name is, like Facebook or wwwi.onion, you need to select introduction points. This is done by randomly selecting 3 Tor relays from the consensus. So the consensus is a list of every available relay in the Tor network. Everybody who's a relay in Tor appears in that consensus. Everybody knows that list. So the hidden service goes and chooses its introduction point. Right? It chooses 3 random introduction points, and then it needs to calculate a descriptor ID. The descriptor ID of the service, the hidden service, is needed because you need to choose a hidden service directory. In Tor network, only 3 hidden service directories know of your service, not everybody. So how do you choose these 3 hidden service directories that know about your service? Well, you do a base 32 decode from your name, from Facebook or wwi. You get your result, you apply a hash with the timestamp. It's very important. And that is your descriptor ID. This hash with the timestamp is being done because your descriptor ID changes daily. So you have different hidden service directories daily. They change them daily because they want anonymity and privacy. After you have the result, which in this case is CPW whatever, you select the first 3 relays in the consensus which follow this result. So will the client. When the client will try to look at arrow number 3, right? Now the hidden service has the introduction points, selected the hidden service directory, and now the client can call to the hidden service directory. In order for the client to call to the same hidden service directory that you selected, this is why you always choose the first 3 relays, okay? So the client will do the same exact method and reach the same hidden service directory that you chose to represent you. After the client has the hidden service directory for your service, it receives a message from the hidden service directory telling him, look, the hidden service has the following introduction points. These introduction points are being communicated to the client. The client now knows the introduction points. The client establishes a rendezvous point that only he knows. This is randomly selected from the consensus list, so it has nothing predictable about it. The rendezvous point is known, and it communicates the address of the rendezvous point to the introduction point of the hidden service. And the hidden service now receives from the introduction point information that you have a client waiting for you at that specific rendezvous point. Now, what you should also know is that every arrow on this picture is actually 3 different Tor relays. So between the client and the hidden service, you have 3 different relays here, 3 different relays here. Relay 1 knows who the client is. Relay 2 knows that the client is relay 1. Relay 3 knows that the client is relay 2. So the anonymity goes on through the chain. Nobody knows who actually asked about the hidden service. So it's a very powerful scheme of anonymization. And we're seeing bulletproof hosting services moving towards Tor. So in this slide right here, the first level proxies with the second level proxies are starting to communicate over Tor. So they don't longer use IP addresses, they use .onion domain names. So this complicates things a lot. We actually did do several takedowns on layer 1 proxies. They were operational within 1 hour, back online. The layer 2 proxies were operational within 24 hours after we took them down. well, when they move to Tor, that presents an interesting challenge to law enforcement as well as security industry. And it's an interesting challenge. And that's why Cătălin said that we're hiring, because as a challenge, we are willing to start with everybody if you want to hop on. I think I have some more conclusions, Cătălin, but
If I may add something, so besides the fact that we're hiring, I'm not going to play spot the Fed with you guys, but if there's any law enforcement agencies or local certs here that want to collaborate with us on these takedowns or investigations, please make yourself known after the presentation.
Right, so you can reach me and my team at forensics@bitdefender.com. Thank you for your patience. Hopefully you guys, I did a good explanation of the topic. It's the first time I'm doing this presentation.
I confirm.
Questions, I think we're ready for questions, for Q&A. So help me God. There we go, Jay. Mother. Is this for Cătălin, right? Question.
Hey, great presentation, by the way.
Thank you.
Good game. So I guess my question is, how did the clients access the Onion services?
How did the client access the Onion services? I just did 50 minutes of speaking about it. But I did a good presentation.
Want to redo?
The organized crime, right? They set up some sort of relay that would relay the packets from the client to the Onion service, or how did that work?
You can have two scenarios, I understand now. First of all, you can have your victims connect to your CNC server via Tor, which means you need to add in the malware some routines for connecting to Tor, which is easy. See TorLocker for that. Or you could have your Bulletproof hosting infrastructure work via Tor, not via hard-coded IP addresses.
Well, I'm talking about the second scenario that you mentioned. So you have your client, which is in plain internet, right?
Yeah.
And you have your hidden services behind Tor.
Yeah.
How do you tell the client to use do they use a Tor relay of sorts to make the client connect to the hidden service?
I suppose so. I don't know yet. I still have to investigate on that. I mean, you're asking me how does a Bulletproof hosting environment look like in a Tor network?
Yeah, how does the client, this is something that you can actually see in forensics. If you study how the malware behaves and how the malware connects to the hidden service, you should probably see how exactly does it do. I mean, I'm talking about not the scenario with the Tor server locally, but the one where the client in plain internet connects to the Tor service.
So this, no. This is the victim in the plain internet, right?
Yep.
And where is your Tor relay? Right here or right here or?
Well, you said something about Onion services, right? Which are in Tor.
So you'll have your proxy one layer be.
Okay, so the proxy one is the one that relays the traffic from the client to the Tor service.
Yeah. Or you could have the victim have some client of Tor in the malware itself. Okay? Whatever you like. Please choose, Jay. I know you want to get.
I'm pretty sure they offer full services, so you get to pick.
They're pretty expensive. Any other questions? Lucian. Oh my God, I can see myself.
So I have like a question and a follow-up question. The first question is what you are suggesting. So you said you are hiring and you are looking to, for a solution to this problem. That solution would basically be de-anonymizing Tor, finding a way to de-anonymize hidden services, which if that happens, it endangers the whole Tor network itself, which has legitimate uses for legitimate users to protect activists, journalists. And how do you, I mean, we know like the law enforcement point of view, they just want to like be able to identify hidden Tor services, and we know the privacy activist point of view, which is that they don't want the Tor network. They want the Tor network to be safe. So how do you strike a balance against that as like a security vendor? And if you don't manage to solve this problem, one of the solutions would be basically eventually to identified the Tor client as bad or suspicious or whatever. Is that something that we might end up doing, like in the antivirus industry, like flagging Tor as a potentially unwanted application because you don't really know if it's used as a client legitimately or if it's embedded in malware?
So let me see if I understand the question. First of all, if you're hiring guys, what will you have them do with Tor? If we're going to take Tor offline as a privacy tool, no, we're not going to do that. We're going to look into ways of helping clients and users to stop being victims of this bulletproof hosting infrastructures. Once we can map the bulletproof hosting entry points, we could stop users from accessing that. But Cătălin is the one that said we're hiring, so he should answer the question.
Why, thank you, sir. Well, let's talk about the balance, I guess. I mean, the balance has been always an issue within the security industry. How do you offer enough security without striking on the privacy thing? The truth is, we actually don't know what would be the good balance. I mean, our main point to solve is to offer clients protection so they won't get infected, lose money, whatever. We're personally not interested into finding out who is the bad guy, we're catching the bad guy. That's the law enforcement agency part of problem. So what would be a good balance? I don't think anyone in this room knows the answer to that question. Okay. There will ever be a balance, or what are you saying? Fair enough.
What I'm saying is that you can, I mean, let's take that setup, right? Where we have like a layer 1 proxy that connects over Tor to a layer 2 proxy or the entire infrastructure, right? So you want to find out the layer 2 proxies, which you can because they are Tor hidden services. And you want to identify the real IP addresses and domains of those servers, right? That's the key issue there, right?
I'm not trying to identify the real IP address because I'm not law enforcement to take them down. I need to stop the victim from calling to proxy level 1, first of all.
Okay.
And then if I can help law enforcement understand that the threat is becoming more prevalent, I mean, we're seeing a lot of connections going that way, then we could help them out and they should do their thing. I don't know. But if I did explain myself correctly, the hidden service directory has some flaws in it. So you can actually see how many requests are being served up to a service without owning it. You don't know the source of the request, but you know how many there are, right? So you can see that a specific CNC server is being more and more and more, is seeing more and more traffic.
Okay, so
that's information
you
which
don't
could be
necessarily have an issue in this setup where you can easily identify the layer 1 proxies, right? Yeah. But you have a problem where the malware has an embedded Tor client and connects directly
That's
to
a
Tor.
real problem, yeah. Okay. But you can tackle it from antivirus solutions, anti-malware.
We're not here to sell,
Yeah.
come on.
Yeah.
There's more questions there.
I guess you have quite an install base with Bitdefender. Do you ever use information gathered with Bitdefender? Like I know some antiviruses, for example, use unencrypted connections like SMTP, for example, to figure out if email has viruses or something. But do you ever use to gather data on Tor? And besides this, I have one small question. Does Tor hidden service require a public IP? It doesn't, right? Like I can have it in behind the LAN, right? As long as it connects to the Tor. Thanks.
You can be a client in the Tor hidden service from your laptop, but you cannot be a relay if you're not in the public internet. You need to be reachable. And the first question was about monitoring.
Getting data with Bitdefender about this type of networks. If you use like, if you use the install base of Bitdefender, basically the computers that
customers.
yeah, the customers to get the data on various malware like this?
You want me to take the hard one?
Yeah.
It's not really hard. I mean, the only information we get from customers is when we detect a file. So we get a report, and so we can have, at the end of the year, a statistics of top 10 viruses we identified in the world. So that's all.
I've got one, and it has nothing to do about gathering data. If you want to stop the chain, right, because that's your point, why not actually collaborate with the guys over at Tor and mark them as bad relays?
You can certainly do that. You could do that. That's an idea.
They're gonna probably come back up every certain amount of time, but
They'll probably come up every hour. But yeah, you could have an API connection with Tor guys and tell them real life.
Yeah, this is a new
stop
one,
that, no,
new
stop
one.
that, no, stop that, no.
that happens
It's
anyway.
a trust issue. I mean, who are we so that the guys trust us? Who are we that we, I mean, we need to talk.
Those are not relays. Those are the services. It's not the same thing. The Tor guys can ban Tor hidden service. They can just flag a relay as bad, but they can flag a hidden service as being bad because hidden service is independent.
You know what will this turn up into if we take this approach? You know the game with the board and ducks coming up and you have to hit them with a hammer and they're all showing up again? That's probably going to happen with taking down parts of the Tor or flagging them.
Can you actually, since you are an antivirus and you run on a local computer, and there's a Tor client, whether it's a legitimate Tor client or some implementation of it, can you actually see where that Tor client, what kind of onion addresses it's trying to reach, since you have access to one of the end-to-end encrypted ends, basically? Because you have access to the one end of the encrypted connection, right?
Yes, you can.
See where that client is trying to connect to what onion addresses, and can you like flag them as malicious, just as you flag malicious URLs and other.
Yeah, so the question was if we have access to the victim as an antivirus solution, if we could see the onion that the victim is trying to access, and the answer is yes. I mean, you can see where it's heading.
How do you differentiate which ones are malicious and which aren't?
Well, that's a topic of discussion.
If you identify, hey, hello.
You got the mic again.
Jesus Christ.
So if
Let's
you
just go.
identify an onion service as malicious, as a CNC or whatever, is it legal for you to try to hack it, for example?
No.
Even though it's
Straight
malicious.
face. Straight face. No.
It's probably going to be legal in the Netherlands. I think they're talking about law or something. No, it's not?
No?
Oh, well, no.
Unfortunately, the time is up for the presentation. You can speak with them in the coffee break, but yeah, it's fine.
Thank you.
Okay.
Thank you very
Thank you
much.
so much.